In this video, I'm going to go over question 4 from the non-calculator, paper 1. We have position vectors of points P and Q given, and we're asked to start by finding a vector equation of the line that passes through P and Q. So in the vector equation of a line, it should take the form R equals A plus B times T, where R and T stay as variables, and A and B get replaced with vectors. So this can be any point, right? Any point on the line. So in this case, I can put P in there, I can put Q in there. This is the direction vector. You can think of it like the slope. And so in this case, we're talking about the direction vector that goes from P to Q. So you can think about this as vector PQ, which is not given, and that's what we'll have to find. So here we could put P or Q, and then we have to figure out the direction vector PQ. So in order to figure out the direction vector PQ, you might want to write P as 3 components, 1, 2, negative 1. You might want to write Q as 3 components, 7, 3, negative 4. And then to figure out vector PQ, we'll subtract Q minus P. So 7 minus 1, 3 minus 2, negative 4 minus negative 1. And you could have done this in the other order as well. There are many correct answers to this question. So 6, 1, negative 3 is one of the options. I could have just as easily done vector QP. All it says is that there is, find a vector equation of the line that passes through P and Q. It doesn't say which direction. So 6, 1, negative 3. Now I can fill in the equation of the line as R equals, staying as a variable R, any point, so I'll use point P, 1, 2, negative 1, plus the direction vector 6, 1, negative 3, times T. Okay, so that's the vector equation of a line through P and Q. And then it says the line through P and Q is perpendicular to this other vector, 2i plus nk, find the value of n. So the line through P and Q is perpendicular to that vector, means that this direction vector that we used, 6, 1, negative 3, is perpendicular to that vector. So we need to pull out what the vector up there doesn't have a name, so we can call it 2. There is no j component, got to be on the lookout for that trick. So 0 as the middle component, and then n is the k component. So between these two vectors, we are perpendicular. That means the dot product of these two is 0. So for perpendicular vectors, the dot product is 0. So we can set up 6 times 2 plus 1 times 0 plus negative 3 times n equals 0. That's the dot product. I have a 6 times 2 is 12. This goes away. Negative 3n equals negative 12, and n equals 4. And you would have gotten the same result for this even if you had used the direction vector QP. And that's all.